Hey folks, I'm Chuck Black, and in this lesson we are going to talk about how in Python everything is an object. Now before I get into it too much, I want to point one thing out to you, and that is this. I've already recorded a couple of video lessons on this in my 52 weeks of Python. As you can see, there's the 52 weeks of Python in 10 minutes version, which is about 8 minutes that you can watch, called Everything is an Object, and there is the original long form 45-minute version of Everything is an Object if you want more detail. In this lesson, in this video, what we're going to do is attempt to do it even faster. So let's get started. So probably the best place to start when we describe what we mean when we say everything is an object is to look at traditional programming languages. In those languages, variables would point to pieces of memory that held values. And so whether it's an integer, whether it's a floating point, whether it's a string, it just points at a location in memory where data is stored. With the advent, however, of object-oriented programming languages, we came up with higher level things called objects. And these had not only the value, but they also had important stuff about it, like the type of data and the reference count, which kept track of how many different variables had pointers that were pointing at that piece of data. In addition to type, there were other things as well, such as we would have methods, which are basically functions that are part of an object. And you could get the length, you could get equality or greater than. If it's a string, you can do split, strip, etc. There were all these functions that you could call on your particular object. And that is the way that it worked with higher level objects in the more advanced programming languages. And the idea is with Python, everything is an object. It doesn't matter if it's a simple thing like an integer like I or a string, everything is an object. So in order to see what all of this means, let's open up a terminal window here and let's run Python and examine the variables that I create. So what I'm going to do is I'm going to type in Python 3 to run the Python interpreter. Once I have done that, I'm going to create a variable called I. Here you can see I equals 1. So at this point, the value of I is 1, but it's not just a value, it's actually an object. So if I say IDI, that is going to give me the actual location in memory that the object I is located. Next, I can say type I. This is going to give me the type of object. Now you can see this word class. That's an indication that this is actually an object. So if we look here, it's doing this thing that you see on the right. It's got a value, but it also has a type. There's a reference count, etc. And there's other stuff going on in the background. Now, if I was to do something different where I was creating a string, I'm going to create a string called everything is an object, and I'm going to print that out. And now I'm going to say ID of S. That's going to give me the memory location. We don't care too much about that right at this moment, but there is a location for that object. When I say type S, it's going to tell me that this is of type string. It's actually a class of string. Now here I am showing you 1. I can do something. I can do 1 or I dot, and this is going to give me all of the functions that I can call. Remember, we talked about the member functions that are available for all of these objects. So I, even though it's just a simple integer, I can do all of these interesting things for it. Now, if it's S, then S is a string, and you can see there's a much larger number of functions or methods that I can call. Some of these will seem familiar to you. We can do things such as, let's see if I can find substrings in there. I can do a replace to replace pieces of the string. We've done split and we've done strip before. All of these things are available for our string object. Even though it seems like just a simple variable that points to a piece of memory, it's actually an object on which I can run all of these member functions. Now this discussion of everything being an object gets interesting and very important when you consider the idea of objects being mutable versus immutable. A mutable object type is able to be changed, and an immutable one can never be changed. This doesn't mean what you're probably thinking it means. An object like an integer, which you think you can change, is actually immutable. And what that means is that a brand new object will be created with the new value. And the same is true of strings. Strings are immutable. Lists, on the other hand, are mutable, meaning they can be changed. So you can add items to a list. And the ramifications of this are going to be apparent when we begin to look at some simple Python statements and what the ramifications are. So what I'm going to do is I'm going to say I equals 1. That means I is pointing at an object which has the value 1. Now I'm going to say j equals I. That means j is going to be pointing at the same object that I is. So you can see they both have the value 1. At this point, I'm going to say I equals I plus 1. So we know that the value of I is going to be equal to 2. So when I print out I here, you will see that the value is actually going to be 2. Now the question is, what is going to be the value of j at this point in time? This is a $64 million question, and lo and behold, the value of j is 1. So what's going on with that? That seems kind of strange. Well, this has to do with the immutability of integers. Python had to create a brand new object to hold I and to make that equal to 2. So I and j no longer mean the same thing. Now, a list, on the other hand, is mutable. Here I'm creating a list with the values 1, 2, and 3. I'm going to create another list called L2, which is pointing at L. And now what I'm going to do is I'm going to take L and I'm going to append something to the list. So I'm going to append the number 4 to the list. Now L, as you can see, is a list with the values 1, 2, 3, and 4. On the other hand, what's L2 going to be? This is another $64 million question. And lo and behold, it's exactly the same value as L. So this is the opposite of what happened when we looked at I and j before. With I and j, we made a modification to I, and j ended up being different from what I was. Whereas with the list, I made a change to one of the lists, and it was the same. So let's have a look at what we're talking about here pictorially. Here's my I and j example in the discussion mutable versus immutable. Remember, integers are immutable, meaning they can never be changed. So Python, when I say I equals 1, Python creates an object with a value of 1 and has I reference or point to it. So I is pointing to this object with the value of 1. When I say j equals I cause j to point at the same object that I is currently pointing to. So they're both pointing to the same thing. When I say I equals I plus 1, remember that object 1 is immutable. It cannot be changed. All right? So what's going to end up happening when we end up performing this statement, I equals I plus 1, is you're going to see that Python is going to create a brand new object. It's going to assign it the value of whatever that's going to be. In our case, it's 2. But j is still left pointing at the original object, and that is why the two values actually end up being different. J still points to the object that's 1, and I now points to this brand new object. And that's what we're seeing here in this code when I say I equals I plus 1 and I look at I and j. And I don't have a pictorial example of the lists, but with the list, it is mutable, meaning you can change it. So when I took L and appended 4, then L2 pointed at that same object, and its value now has a list which has 1, 2, 3, and 4 in it. So that's mutable and immutable. You can look at the long form version of this, the lesson that I did in 52 Weeks of Python, if you're interested. But hopefully this gives you a little bit of an idea of everything is an object and immutable versus immutable. So hopefully this discussion of how in Python everything is an object, and also we added in mutability versus immutability, hopefully that made sense to you. If not, if you have questions or comments, please let me know. And as always, thanks for listening and see you next time.